All right, guys, here's what we're going to do today. We are going to uh, graph quadratic inequalities, which I think will be rather intuitive to you, at least off what I saw yesterday. Then we're going to solve quadratic inequalities, which may have a little bit more going on. Let's get started. So the first goal is you got to be able to solve this quadratic or graph the quadratic inequality. Number one. So I'm knowing that's in standard form, I'm going to go negative b over 2a. It's negative 1a, right? A. Um, then we're going to get, we get negative 1 there. So our vertex is going to be at negative 1, comma, and I'm going to plug it back in up here. Right? So negative, parentheses, negative 1 squared minus 2 times negative 1 minus 1 equals 0. So it looks like our vertex is going to be at negative 1, 0. The other thing I know is here's a y-intercept of negative 1. Mirror it. And I also know there will be another point if I plug it in at 1 comma negative 4. You can plug it on your calculator to verify. Now, from there, I'm going to look at this sign right here and know that A, it needs to be dashed. Means not equal to, so we got to put a line there that means not equal to, so it's not part of our solution set, right? Now the next thing is being an inequality. It means there's a whole solution region. When we say less than, it means it's under the vertex. So really what our shaded region is going to be is right in here. Now, overall, what this really means, just for an understanding's sake, is if we pick a point in the shaded region, say right here, 0, 6, right? It should work in the original given inequality. So if we go 6 is less than, that's a negative 6, right? So negative 6 is less than 0 squared minus 2 times 0 minus 1. Is negative 6 less than negative 1? Yes. But that also means then if we pick something outside of the solution set, say right here, say we pick 0, 0, it's not in a region, then we go 0 is less than 0 squared minus 2 times 0 minus 1. We get 0. Is 0 less than negative 1? And of course it's not. And that follows with what we're saying. In the shaded region works, outside of the shaded region does not. So moving on to part B, or question B. Negative b over 2a gets us negative 1. So our vertex is going to be at negative 1, comma, and I'm going to plug in negative 1 to the original. Negative 1 squared plus 2 times negative 1 minus 8. Get negative 9. So now I got negative 1, negative 9, and then y-intercept of negative 8 and its mirror. Then if I plug in 1, I think I'll get this. And if I really wanted to, I could plug in 2. Plug in 2, I think I'm going to get there. This tells me right here, solid line. And this tells me go above the vertex. So above the vertex would end up being on the inside of the parabola, on the inside. So we fully expect, and not that you have to do this, but if we pick 0, 0 here in the solution set, that 0 is greater than or equal to -8, which is, of course, true. So it means we've got it right so far, right? Powering on, negative b over 2a ends up being it might just take a bit because there are a bunch of them. So if I got 1/4, I'm going to type it in. And get negative 1.125. This is a really silly problem. So we're going to have a vertex of 0.25, comma, negative 1.125. Really silly problem. Sorry. All right. And then if we go -1, and try this whole problem's muck. All right. I shouldn't be using this one. Let's skip. I don't like those decimals at all. Okay. So going on to the next one, negative b over 2a. And then if we put in a vertex, we're going to get 1 comma negative 1,5, y-intercept of 4. 1, 2, 3, 4. If we plug in a 3, we'll get 1. We can get its mirror. If we plug in a 4, I think we'll get -4. This tells me I need to dash it. Now, this sign is also telling me go greater than the vertex, so above the vertex would be right there. Again, if we want to test it, right? If I want to test it, say I pick a point of 0,8, it should work. 8 greater than or equal to -0 squared plus 2 times 0 plus 4. And in fact, 8 is greater than 4. So moving on down. Now you're going to do a system of inequalities. So we got 2 of them to graph. Negative b over 2a for the first one is just 0. We plug in 0, we get 0, comma 3, which then means our graphing this one first, our vertex and our y-intercept are the same thing, so we just need to start plugging in points. If we plug in 1, we'll get 4 back. No, we won't get 4 back. If we plug in 1, we will get 2 back in its mirror. If we plug in 2, we will get -1 back and its mirror. If we plug in 3, I think we'll get -6 back. That tells us it's a dashed line. And it tells us that we should go below the vertex, so we'd be right here for this one. Now, starting all over on this one, we'll go negative b over 2a and get -1. We plug in -1. We'll get -4. So we go -1, -4. We also have a y-intercept of -3 in its mirror. If we plug in -3, we will get 0 in its mirror. If we plug in 2, we will get 5 and its mirror. Now, this line tells us solid.
And how did you draw that?
Oh boy, I didn't graph that point right for its mirror. So, right there. Now, still got it wrong, as William pointed out. So I go like this. Now, what does it also tell us? It tells us here, it tells us we're going greater than the vertex, so we go like this. Now, notice where the overlap is. The overlap that we really, really, really want is right where it works for both inequalities.
You can use paints.
So, when we go with both the system, when we're graphing a system of inequalities, we are looking for the place where it works in both inequalities at the same time. So where that works is where that overlap shading was, and that's our solution set. Let's see if we knock this next one out fast. All right, so if I'm graphing this one, we will have a solid line.
And did you that play force them?
So now when we go solid line, and this says we're going less than the vertex, so we're less than the vertex over here, right? And we'll go to the next one. Again, negative b over 2a means 0. If we plug 0 into here, we get minus 3. 0, negative 3 is there. We get some points there and there if we plug them in. There and there. Love you guys. Logan, I'll figure it out, all right? I'll have a whole bunch of them for you. Okay, so it's a dashed line because that's dashed. Now that says it's above the vertex, which means above the vertex in this one, which means our solution set overlap is right in here. And then everything else is kind of hogwash. So we go like that. And our solution system, our solution to that system is as seen. Okay, something that's a little bit harder would be to solve the quadratic inequality algebraically. The first thing we do is if it's equal to 0, that should say x in it. So the real problem should say something like x squared minus 3x minus 4 is less than 0. So the first thing we want to do is find some critical values, find the zeros, find the roots, as it were. I do believe this thing factors, so x minus 4, x plus 1. So 0 product property, my critical numbers because of this one is 4 and negative 1. Now, on a number line, if we got 0, negative 1, negative 2, negative 3, negative 4, we know that our whole inequality bases around this, right? So what we're going to do is we're going to test a 0 and see what happens, all right? Or what we'll do is see if a 0 inside of here works. So if we plug a 0 squared minus 3 times 0 minus 4, is that less than or equal to 0? Is negative 4 less than or equal to 0? Yes. Right? So that's got to go that way. Now, just to make sure, say we tested a 5 out here. If we put a 5 in, 5 squared minus 3 times 5 minus 4, and we'd say, is 6 less than 0? Of course not. So that must mean that 4 needs to go this way, which means overall that we have this compound inequality where we're trying to say the only solutions that work are between negative 1 and 4. So you're going to, and it should really be, and you guys know this, right? It should be an open dot at 1 and 4, right? Because of this being an open dot. So what we're really writing as our solution is a compound inequality that represents that, right? This next one, it says we can use Desmos. So I want to remember 3x squared. Remember 3x squared x squared minus x minus 5. So what we're trying to show here is on this one, right? Critical values there right away. So instead of having to solve for that, we know them. All right. The next thing will be, if we're looking at the sign says greater than or equal to. So when we say greater than or equal to, we can say that, let's just go ahead and check 0, 0 as our math. All right. If we go 3, 0 squared minus 0 minus 5, is that going to be greater than or equal to 0? That's the question, right? That goes to 0, that goes to 0, and we end up at this. Is that? Of course not. So when we look at this graphically, what we're saying is in between here will be numbers that don't work. So it has to be numbers going this way and has to be numbers going this way. So when we're looking at the answer, it would be x is less than negative 1.135, or x is greater than 1.468. And that's how we would do it. I'm going to do in this next section is I'll do one algebraically and I'll do one Desmos, so we have to do it all over again, or more practice. So imagine we're going to do this one algebraically. The first thing we need to do is get it to 0, right? Then what I'm going to do is probably the quadratic formula, so negative b plus or minus the square root of b squared minus 4ac all over 2a. So I get negative 3 plus or minus, let's see, simplify the discriminant, 25 over 4, which is negative 3 plus or minus 5 over 4, which means x, our two critical numbers then need to be x equals negative 2 and 1/2. So again, just getting rid of some of this, if we imagine a number line here, 0, 1, negative 2, and 1, 2, and we say this is going to be a closed dot, so negative 2 closed dot, open dot at 1/2. An easy test point is in between those two. So we'll test 0, 0. I'm going to say, does 0 work in this? Original inequality. And we'll say, is 0 less than or equal to 2? Which is, of course, yes. Which tells me that our solution set is between these two dots. So then what we need to do is write an inequality that represents this compound graph. So it would be negative 2 less than or equal to x less than or equal to 1/2. Okay, now negative 3x is 4x plus 1. I'm going to go back to Desmos for the second one just to try that one. So negative 3x squared minus 4x plus 1. I'm going to see that two critical values are there. So in my inequality, what I'm going to do is, seeing that 0 zeros in there, we'll make that an easy test point. So is negative 3 0 squared minus 4 times 0 plus 1, is that less than 0? Is that less than 0 is my question. So this goes to 0, this goes to 0. Is 1 less than 0? Of course not. So what that tells me is our solution set must be out here and out here. I'm going to reemphasize that that's an open dot thing. So our answer would be x is less than negative 1.549, or x is greater than 0.215. That would be our solution to this one. Let's try one more. All right. First thing I'm going to do is make 2x squared plus add to 5x over plus 2 greater than 0. So 2x squared. So I'm actually, I think, going to reuse Desmos one time. So if we erase all this, get it all out of the way, if we go 2x squared, notice I got critical numbers at negative 1/2 and negative 2. I'm also going to, let's see, greater than or equal to 0. Just remind myself this needs to be greater than or equal to 0, right? I'll check one more time. I'm deceiving myself. Not equal to. So greater than 0. So I'm going to check a number in here, call it negative 2 comma, no, not negative 2, that's not negative 2. Let me, so we'll call this negative 1 comma 0, and we'll test point it. So if we go 2 times negative 1 squared plus 5 times negative 1 plus 2, is this greater than or equal to 0? 2 negative 1 squared plus 5 times negative 1 plus 2. I got 94. Do I got that? Oh, silly. 2 times negative 1 squared plus 5 times negative 1 plus 2. I got negative 1 greater than or greater than 0, which is a big no, right? Which means it can't work in here, which means it's got to go from 1/2 this way, 1/2 this way. I'll notice it's an open dot, so I'll go x is less than negative 2, or x is greater than negative, what is that, 1/2, negative 1/2, negative 1/2, and that's our answers. All right, go ahead and start on the textbook problems at the end of this worksheet.